Hey guys, today we're going to talk about finding the area of an equilateral triangle. There's a special formula for this, and we're going to try to derive it. We're also going to look at some of the special relationships in an equilateral triangle, some of these special segments that we have. I think I could do better than that. So let's say we have, this is our equilateral triangle right here. Now we do know, and I'll write this off to the side, the equation from yesterday was the area of any regular polygon is 1/2 the apothem times the perimeter. Our goal today is going to be to figure out an equation for an equilateral triangle and have it in just terms of the side length. So let's go ahead, and I'm going to start off by first investigating into some of the relationships of different parts of equilateral triangles. So these purple marks, these are going to be the radius of this polygon. And in green, I'll just draw in one. This will be the apothem. So radius, apothem. And we'll just use blue. S will be the whole side length, meaning that this is 1/2 and this is 1/2 for those little right triangles that we make. So first thing we're going to do is, if we look at the central angle up here, these three angles, it would be 360 divided by 3. So like this black angle here, that would end up being 120 degrees for the black angle, and this black angle here. And then down here you would end up with 180 total. So each one of these would be 60 degrees. And I'm going to take that triangle, so we'll go to this bottom one to the left, and I'm going to draw it out here. We have the right angle, the apothem, the radius, and 1/2 the side. So this angle up here is going to be 1/2 of that 120, so it's going to be 60, which is nice because then we know this is 30. And then you can look at some of the relationships. The relationship between the radius and the apothem. Well, the radius is going to be equal to double the apothem in an equilateral triangle. That's a good relationship to know. The one that I'm really going to focus on is what's the relationship between a side and the apothem here. So if you look at the right triangle that we have, we would know that 1/2 of the side, because that little segment would only be 1/2, it wouldn't be the whole side, 1/2 of the side is equal to the apothem √3. And let's say we try to isolate A here. So the apothem is equal to, well, S over 2 √3. And then you can go ahead and rationalize, and you're going to end up with S over 6, and we'll have √3 up top. So that's the relationship between the side and the apothem. The side times the square root of 3, all divided by 6, is equal to the apothem. Kind of messy, but that's their relationship. It's going to help us derive a nice formula. So let's go back to this formula up here in red, and I'm going to bring it down here. So the area would be 1/2 the apothem, and instead of perimeter, I'm going to write it as one of the sides times the number of sides. But the number of sides we actually know here, it's 3. So apothem times 3 times the side length, that would be the perimeter. And to clean it up even more, we'll just make it 3/2 apothem times the side. But we already know the relationship between the apothem and the side, and I'm just going to go ahead and substitute that in. So 3/2 we'll keep out here, and then it's going to be times the side times radical 3 all over 6. That was substituting for A, so we have to multiply by the extra side. Now you can do some simplifying. 3 becomes a 1, 6 becomes a 2, and we're going to go over here. So we're left with, well, up top, we're left with 1 times the side times square root of 3 times another side. So that simplifies to side squared times square root of 3. And on the bottom, we're left with 2 times 2, which is 4. And this right here is a special formula to find the area of an equilateral triangle. It has to be equilateral triangle if you know just the side. So if you know the side length, you square it, multiply by square root of 3, divide by 4. That'll give you the area of the triangle. It's a special formula for equilateral triangles, and we just derived it. So we can go ahead and we'll do an example of this together, how we can use it. And I mean, even if you don't know this, you could fall back on this formula up here, but knowing this will make it a little bit quicker, and it's nice to derive new formulas with relationships that you know. So let's say we want to find the area of a regular triangle or an equilateral triangle with an apothem of 8. So we're looking for the area. We have an apothem equal to 8, and it's an equilateral triangle. So I'll go ahead and draw a nice triangle here. We know the apothem is 8, so I'm going to focus that right here on the bottom. We know this distance down is 8, and that's all we know. But like with the last equilateral triangle we drew, we know we're going to create, when we draw the radius in, we're going to create some 30, 60, 90s. That's going to be nice because this side is 8. And some of the things you'd be able to tell are, if this is 8 and those 30, 60, 90s, this would be 16 here, this would be 16 here. And then on our bottom, we would end up with what would be 8 radical 3. So our whole side length is going to be 2 times that. So it's 16 times the square root of 3. And then we can use that formula that we just had. So the area is going to be 16 times the square root of 3 squared times the square root of 3 all over 4. So when you go ahead and do this, you're going to end up with, I'm just going to write it like this for now, 16 times 16, that's 16 squared, times 3, square root of 3 squared is just 3, and we still have root 3, all over 4. 4 cancels, this becomes a 4. So 4 times 3 is 12, times 16 is 192, and you still have the square root of 3. So our area of this triangle would be 192 root 3 units, and you're all done. If you didn't remember this formula, there are other ways to do it. You can fall back on other things you know. Another way you could do this, I would draw the radius going up, because if the radius is 16 here and here, the radius is going to be 16 up here. So we have that 16, and then you can use 1/2 base times height, because we know the base, the whole length was 16 root 3. So your base is 16 root 3, your height would be 16 plus 8, so you would have 1/2. I'm just going to write, instead of 1/2 times 16 root 3, I'm going to write 8 times root 3 times 24. And that'll get you the area of the triangle as well. 8 times 24 is, there's your 192 again. And there's still your area. So it's nice to know the formula. If you forget it, you can fall back on that other formula that we know. Alright, that's all we have for today, guys. Have a nice day.